All right, let's get started. So, welcome to Functional Programming. It's one of my favorite lessons in the whole program. So I'd mentioned, I believe earlier this week, that we haven't spent a lot of time talking about paradigms of programming, for a very good reason. They tend to be super abstract. These are philosophies about how code should be written and organized. And when you're getting started, how about just write some code? But what we end up doing is we start mixing and matching from these philosophies. And sometimes that's productive, sometimes that's counterproductive. And so my hope is by explicitly studying a little bit of functional programming and a little bit of object-oriented programming, you see where these ideas come from a little bit, and you can be a little bit more thoughtful about how you apply them. So by the end of this lesson, I hope you'll be able to ID some tenets of functional programming, and then I hope you'll be able to refactor code using some functional programming principles. So to start with, our core concepts in functional programming. Oh, why should I just give it to you? Got to work for it a little bit. So I'm going to put 6 minutes on the clock, and I want you to look up principles of functional programming and keep track of what you find. Go. So, why don't you turn and talk to a neighbor and share what you found. Let's do 2, 2, 3, 2, 2, 3. Go. Ah, come on, man. Get your shit together. All right, let's get back together. So, I want to do a survey of the groups. This group right up front, what's one of the principles that you found? All right, that's a great one to start with. What's immutability?
Once you assign the value to something, the value doesn't change. You can't really assign.
Indeed. So, question for the whole class, like, if we're going for immutability, what are some things that we can't do? Indeed. So push and pop, right out. Because those mutate the array. What else? What else can't we do? Rita? Reassign variables. So we use const for everything in JavaScript. There'd be no reason to use let. There'd be no reason to use var. It's not reassigning. So who gives a shit? Question for the whole class. Why is that something worth striving for? Immutability. Gets very predictable how something works. Because if you're given a variable and that variable can't change ever, that takes an entire category of problems off the table. Because now I don't need to worry about what the value of this variable is right now. It could be anything else. And this gets to like a sort of interesting relationship that this has with math. Broadly speaking, I'd say functional programming and object-oriented programming. I'd say functional is a very mathematical approach to programming. Object-oriented programming is a very literary approach to programming. And they both have a place, but if you do y equals mx plus b, this is the algebra equation for a line. Yep. So it would not make any sense to say that, like, I've reassigned b to some other value. That isn't parsed correctly. And this is the sense in which we use variables. And in fact, you may have also in school seen this written as like f of x, something like that. Hey, what if we rewrote that as function x, and we returned m times x plus b, and we said something like b equals 3 and m equals 0.5. This, like, this big connection to like math that you've been waiting for in programming, there it is. The way we use function in functional programming is way more like this than the way that we were using it in Ruby, where it's like behavior. It's transformations. If I put 1 into this function, I get, let's see, y-intercept is 3, and slope is half. And so for every x on this line, I get a particular output. That's the return value of the function. Only do that if it's immutable. If this can change what x means, it's not really an equation anymore. Cool. So immutability. Arena and Lizzie, give me a principle. Purity. What's purity mean? Mm-hmm. Absolutely. So if we go back to that y equals mx plus b example, for every x, we get one and only one y. You may remember, like, from math class, you'd say, all right, well, it's not a valid function if you hit the same thing on the y-axis more than once. Like, you can't do something like that, where the same x could give you this y, or this y. That's not valid. Same way in functional programming. We're saying two things, really. We depend exclusively on inputs, like direct inputs, stuff that was actually passed into the function. So this pattern that you've probably done 100 times, where you write a function that we do something like that, not an FP. An FP, you explicitly pass that in, and then you would do something with it. Although you couldn't do this, because why? Mutates it. Now you could do something like return x plus 1, but still got to pass x in. So we're not just expecting anything to exist in scope out here necessarily. There's some exceptions to that that we'll play with. But we generally want to depend on explicit input. And what was the other side of that? This is probably good enough to be its own principle. But that's the input, and then for our output, what? Anyone? No side effects. What's a side effect? But wasn't returned. We're dealing explicitly with things that have been returned out of the function, not like something like reassigning a variable out here, or even something like if x is an array, like pushing something into that array. Not good. And in fact, there's another kind of side effect you may not have thought of. Console.log. It outputs something to the screen. That's not directly returned out of the function. It's additional behavior. So a thing that doesn't mean that you don't do that. In fact, if you had no side effects, you wouldn't have a program. It needs to have some impact on the world. It needs to read something in, and it needs to output something at some point. The difference with functional programming is we're trying to do all the input up front and push all the side effects to the end. And everything in between is data transformation. Cool. Cody and Martin. Give me another FP principle. Disciplined state. What's that mean? Yes. This goes along with purity and controlling your side effects. So rather than just having things like this, where we're just have variables hanging out there willy-nilly, trying to keep that as local as possible and dealing with it that way. Basically, state is the problem in functional programming that we're trying to get rid of. So that leads to some kind of interesting conclusions. So for example, there are functional languages where it is very difficult to create variables because variables are state. That's like by definition what they are. So instead of taking something and instead of taking an expression and assigning it into something and then using that, just use the expression. Don't store it first. Because what that does is it gets us to this place where there's no concept of time. Time is the problem. This is what state gives us. But oh baby, it's also 90% of the problems we run into in programming is that something happened at the wrong time. Some state wasn't set yet. But if you're just dealing with the expressions, it kind of all happens at the same time. And while that sounds confusing, you've done this before if you've done any kind of spreadsheet programming before. If I have these like cells and I have this number and this is that, and I say that this is C1 times 2, there's no real concept of time here. Nothing's been stored in a variable. These things depend on each other, but we don't actually give that much of a shit about like a concept of time, execution order, anything like that. We're making statements of fact. That's discipline state in FP. We're saying that this is whatever 2 times this is. We're saying this is this and this together. And what's really cool about this, and hopefully one of you picked this up as a principle, is that if these were formulas too, this doesn't care, this doesn't care. That's pretty powerful. So back group. Any more FP principles you found? That's the one I was looking for.
I'll say that's the last one. I'll say the previous one.
Referential transparency is one of my favorite ones. So what's it mean?
I guess the fact that A here would be basically no side.
Yes. So expressions, so I would say this. Expressions are equal to what they evaluate to. So if I have a function called for, and all it does is return 4, that's the same thing as 4. I could have just swapped those out. Same thing over here. If this is 1 and this is 4, this doesn't care that this is a formula. I could have just written 5 there. It's treated the exact same way. And if that is something that, if we can hop back over to like JavaScript land, there are, I got something that returns the string cat. Cool. Well, strings have length, and strings have like a split method and all these other kinds of things. So in code, I can do shit like const a equals a, and then do a dot length. Referential transparency is I could have also done that, because the expression and what it evaluates to are the exact same thing. If I want, what's some method I can do on a number? So if I do const 4 equals 4, what do I got here? To fixed. Anybody know what to fixed does? Nope. Good guess though. It makes it a string with a fixed number of decimals. So if I say it should go to there, I get that back. Cool. But I can do that, or I can do 4 dot to fixed. Oh, well, let me do it with the literal. I'll bet it'll let me do it if I throw it in parentheses, though. Yeah, there you go.
Why would you use these two like resources like
So imagine, that's a good question. Let's say I have a price that I'm storing as 137, and I buy 4 of them, and I want the, I don't know, average price of what 5 of them would have been. There we go. So like that doesn't work as a price. And so what I can do instead is say, let's use some referential transparency. This expression and what it evaluates to are identical. So I can do to fixed. Like if I were making a cash register app or something like that, That would be a good way to do that.
Do
Cool.
you want it to be a string and not just like
That's like what to fix does, is it just makes it a string. If I need that to also be a number, hey, this string and an expression that creates that string are identical, so I can coerce that with like plus, like we learned yesterday. And now it's a number again. Neat. Any of these tables, any other FP principles that you found? Type systems. This is an area where JavaScript kind of falls flat. JavaScript's type system's kind of garbage. But the idea here is that we have a couple types, right? Got numbers and booleans and objects and arrays. Well, what if we also had data types that were things like person, or chair, or bus, or train, or something like that? And what if we could define an algebra for those things? Like, what does a person plus a person mean? And you can start declaring like mathematical facts about what operations these things can do. And once you have that, you can write programs that you essentially don't even need to test because they can't be wrong. There's this philosophy called make an illegal state unrepresentable. If there's no language for representing something that something can't do, that's an error case that you don't need to account for anymore. Cool. Any other FP principles anybody found? Mm-hmm. Love it. So this is right in our wheelhouse. What's a first class function? Yep. Just like our person data type and our train data type, functions are just another piece of data. And so I can store it in a variable. You can't do that in Ruby. You can't do that in Java. You can't do that in C#. There's no real idea of storing a function in a variable. And once you can do that, that also means that you can replace a function definition with a variable that stores that function definition. It means that we can pass them into functions, means that we can turn them out of functions. We can do anything we can with any other piece of data, except we can also invoke them. Dope. That's a first class function. What's a higher order function? Operate with other functions. Yeah, can anybody else get more specific? Passing a function into a function, and the other one is close. It's a thing that you're right there. Currying is a thing that you would do with the thing that I'm looking for. We can pass a function into a function, or return a function from a function. Those are higher order functions. Cool. So all these things together, that's a pretty good description of functional programming. Everybody confused yet? This is way more like academically rigorous, I think, than OOP is. Yeah. So closures are a way that we deal with this disciplined state thing and purity, depending exclusively on inputs. Because sometimes we do need to access something that isn't explicitly in the function, and we do that via closure. So you could have something like function outer, and what it does is it returns a function definition. And if I have some value out here, or even better, no variable, what if I pass it into this, and I pass something else into this, and I return x times y? Yes, and I'm referencing this value out here, even though it's not part of this function's definition, technically. That's accessing it through closure. And so Aaron mentioned currying. If I go outer 3, I want you to think about what this expression evaluates to. Think to yourself. I'm going to cold call someone. Okay, if you get it wrong. I'm going to call on Gage. What do you think this evaluates to? Not quite. Good guess though. Let's see. Joe, what do you think that evaluates to? It's not 9. Okay, so now we're kind of getting into the ballpark. Like, that's closer, still not quite it. Who's got a guess? Yeah.
The function definition of access would be
That. We return this, except now we can see what that was. Fucking crazy, right? So, if outer 3 is a function definition, what can we do with function definitions? We can invoke them. Referential transparency. Now we get 12. And since we have referential transparency, and this is the same thing as 12, we can do shit like that. Sure. Actually, any brave soul will walk through why this equals 12. Katie, give it a shot.
So the outer 3 is passing 3 as x, so it's going to return function inner y with access to things.
Yes.
And then the 4 is passing into the y value. So you have, now you have the return is access to x and y, so it can be 3 times 12.
Yes. And that's the return value of this function being executed. So imagine that as the same as inner 4, except it can see that 3. That 3 was kind of bound. And that's the same thing, which would make that the same as 12.
For examples like this,
Mm-hmm.
I guess
Mm-hmm.
I guess this example, could you pass in another function for 4?
Oh yes.
So you could like go out to like down.
Yeah. Yeah, let's play with it. So,
I guess with types, you would try to be more prescriptive in what exactly you can pass in.
you'd say they have to be numbers.
Okay.
All right, so yeah, so if I do that same thing Okay, so that's the function that I just wrote. And Katie's question is, all right, referential transparency, we did outer 4 and 3, and if I console log that and run I get 12, right? But with referential transparency, that doesn't have to be 4. That could be something that returns 4 or evaluates to 4 somehow. And so I could make a function called 4 that just returns 4 and swap that out. And now when I run it, still 12. Whoa. That kind of shit's like FP by the numbers.
So, Python is an object oriented language?
More. Python's a nothing language. Okay, I'm going to talk shit about Python for just a sec. So, like, you go, oh, Python's so good for data. And you go, okay, cool. Like, I started learning Python for data, and it's all list comprehensions and, like, for in loops and all these kinds of shit things. It's like, wait, this is, like, functional programming super duper shines with, like, complex data transformations. It's what it's for. And, like, it's so difficult to do any of this kind of stuff in Python. And so I asked a Python buddy about it, and he's like, all right, the reason Python is so big in, like, the data science world is that, like, these people aren't full-time programmers. They're full-time scientists. They're geologists. They're statisticians. Their area of expertise is somewhere else, and they have to get some programming done. So Python is kind of the opposite of Ruby. There's a very strict syntax that you have to adhere to for everything, which makes it difficult to make mistakes. And it's pretty easy to read, and it's pretty easy to learn. So that's why scientists use it. It's not like especially good at anything, honestly.
I was gonna say, this is like, this to me seems so much more like a no-brainer for
Right.
doing complex math.
Absolutely. But like this would be fairly difficult to represent in Python. There are some libraries for it, but imagine yourself as somebody who is like the math of this is like your home base. Programming, I took a class once. Python very much appeals to those people. But if you're a programmer and you're kind of coming at this the other way, you're like, all right, I'm pretty comfortable with programming. Math, oh, like, I'm not bad, but I think these more FP approaches tend to be a little bit better.
Is there a functional, I'm sorry.
Mm-hmm.
Is there a functional language that is used for data science? That is less,
Yep, Scala is great for that. Yeah.
I was gonna say, so then, just like this, I don't know,
Mm-hmm.
Java is pretty functional language.
No, Java's far the other direction. Java's hardcore OOP.
This is like everything we had to do with Java. So it was like all of this functions within functions and a lot of different things and that kind of stuff.
So like some of this stuff is good programming practice. Like closures are not exclusive to functional programming. OOP also uses closures. But like it was Java just got map like a version ago. It's also kind of bolted onto Ruby. So anything you've done in Ruby that had blocks, that's a weird concept in OOP. Like they stole that from FP. Because you notice in JavaScript, we go, all right, I have an array, I map over it, and I take some function definition, right? And then in Ruby, the way that we did that was we would say map do number and we would do implicit return with number times 2 or something. This isn't a function though. Like, I can't reuse that. There's a similar kind of thing in Ruby called a lambda, which is what that is. Like, sometimes you'll hear this referred to as lambda syntax, but we can't really store them in variables. We can't really pass them around. We can't really reuse them. Like, if I also did that again with like a different array right after that, I kind of need to write out that block again, right? That's because like this is not a native concept to Ruby or any OOP language. They're so fucking useful that like Ruby bolted them on, and so did Java very recently. But there you go. There are JVM languages that are super functional. F# is one of them. Groovy is another one. Cool. Other questions so far?
Does using like a global variable that's not originally inherent is just a package function in the computer?
Yes, very. So let's say I do something like x time, come on, man. I'm doing that. And then y is out here in the global scope. Come on, man. That's not pure. Because this wasn't passed in to this function. Now, there's a way that I could make this state more disciplined. And it would be something like, all right, map takes a function definition that applies. Well, what if it's a function definition? Actually, I'm going to write this differently. If I did need to take in this number and some other thing, I could say something like multiply by 2 or multiply by, pass into, and then return the function definition that map is actually going to use. This is actually a pattern that you have to use a little bit in React. So instead of like that. And then this is going to be number times x. And then when I want to use this in my map, I spell it right. And I do multiply by 2. And now, multiply by 2 makes that 2 available, but what it really does is it returns this function that map is going to call every time that can see that. And now I don't need double, because I can triple, I can quadruple, and that's this like tiny functions that do one thing that are super reusable. That's kind of the idea there. Other questions? Yeah, Gage. So in functional languages, you generally don't have conditionals. Like instead of if usually don't do something like that. Instead, you do it the same way you've done in spreadsheets, if you've ever done that before, where you say if condition function to run if true, function to run if false. Something more like that. Same thing with loops. There's really no like concept of a for loop or something like that in functional programming. You do map, reduce, filter, like that's one way to do it. And for ones where that doesn't really apply, recursion is the tool that we're using. So if I have something like, trying to think of a good example of recursive function. All right, so numbers is an array of numbers. Like, if I want to do this recursively without a loop, and for whatever reason, reduce is broken, it's in the shop getting repaired. What I do is I return numbers at 0 plus the sum of whatever is, I should pop that first. Feel like new numbers equals, actually these have names, so I'll say head is that, and the tail is numbers, actually, then number shift, and the tail is numbers. All right, so I've split it into 1 and an array with 2 and 3. And so the sum of these is numbers at 0 plus the sum of the tail. And then that keeps happening. And you only stop doing it. You put like an if statement in here as like, if there's a head, then you do all those things. I don't know if that actually works, but that was what I could do thinking on my feet. But that's the general idea, is that you are continually consuming something until it's gone, and at each step, you're calling the function again with a smaller amount of the problem. That's recursion. Any problem you can solve with looping, you can also solve with recursion. I think some of you picked up on this from one of the like whiteboarding exercises or something. Anybody know what the trade-off is with recursion? 'Cause there's a big one. Blowing the stack. What's blowing the stack mean? It's not memory. These are actually super memory efficient, but there is a fixed amount of instructions that you can queue up. It's not directly related to memory, although that's part of it. So if you think about these recursive problems, I can't actually figure out what this first one was until I get the result of this. And then we get here, and I can't actually figure out what this is until I get the result of that. And so all of these instructions to the computer just keep piling up. And once it gets to the end of them, once it's done, it can start working that down. But we have a limited amount of instructions that we can give it. And so if you run out of slots for that, you get a Stack Overflow. There's ways around that problem in other languages, not really in JavaScript. But the cool thing about that is that this is super memory efficient. If I were trying to do this by like storing temporary variables each time, that's taking up memory. But it's very computationally cheap. Recursive solutions are super computationally difficult, but very memory cheap. So you just trade one for the other. They each have a place.
So are any loops not functioning?
Yeah, and the idea is it's control structures that we don't want. So things like that, that's a control structure. Functional doesn't really have that concept. Same thing with for loops. Those are control structures. You think about like how you would express that in math, and you can't, because math is statements of fact, not a set of instructions. This stuff comes from what's called the von Neumann style of programming, which now we call procedural programming, where we're just telling the computer a set of instructions to do, versus the functional style, which is a set of like formulas and equations and facts that we're working with.
So if you're using like multiple classes in this program, and I know that's another
Mhm.
JavaScript, but if you declare variables, does that go with functional programming?
The idea of classes and objects in general are kind of antithetical to functional programming. So instance variables, static variables, any of them. But with classes, a class is a thing that stores state and behavior. We're trying to get rid of state altogether. Other questions? Yeah. Cool, great question. So, and something that might be maybe more familiar, if I did this Ruby style, I might say something like, actually, what do they? They do and end those, don't they? Actually, Damon, how do the classes in Ruby, those use curly braces, or they use do and end?
They don't repeat anything.
Nothing?
You write class.
Oh, but then you end it. You still have to end it though, right?
Yeah, yeah.
That's it. Space for a sec. Cool. So if I'm doing something like that, and I have an adder accessor for is running, and then I have a method called start train. And what it does is it changes is running to true, but when I initialize it, it's false. So when I make a train, the state of the A line is it's not running. And then I do A line start train, and now the state of the train is running. So in OOP, it's the properties. They can change values. So whatever values they currently have, that's the state of that object. Same thing with a class. You think of that like add all thing that we were doing, and you shovel the things in every time you make them. The state of the train class is no trains, one train, two trains, so on. In procedural programming, there's a state where const y hasn't happened yet, so y isn't equal to anything. And then the state of the application is we have a variable named y and it's equal to this. But curious thing, in this right here, there's no state change. It's just an expression. This is basically, like we just said, 12. That doesn't change the state of the application because we haven't stored any data. So my TLDR on that is properties and variables. That's state. He's got it.
So is the function multiply by x button is for the closure?
Mhm.
Is that saying closure just means that the inner function has access to the variable?
It has the inner function has access to the outer function, even though, and this is the wild fucking part about this. This is the easiest one to like try to get your head around this. When we do multiply by 4, This outer function has completed executing. It doesn't exist anymore. But this variable that it used to have still exists because this inner function closed over it. That's the closure. You will get asked this in an interview, even a junior interview at some point. This is everybody's favorite fucking interview question. What's a closure? So I'd practice playing word golf with this. What is the fewest words you can use to describe this? Because if you start rambling for 15 minutes about this, like, you're gonna get caught. So it's when, more generically, it's not even functions. It's when an inner scope has access to an outer scope after the outer scope has finished. Multiply by doesn't exist anymore. Only this inner function does. Yet, you can still see the stuff that existed because it has a reference to them. That's closure.
So in functional, you wouldn't explicitly define X here,
You did. It's right there.
okay.
I can't redeclare it.
You would do const X equals.
Correct.
Then how do you keep track of input?
Say that again?
Like, I guess how would you know what is input? You're not, I guess I'm thinking like math.
That's what this is.
Oh, okay.
And check this out. We could also do something like const multiply by 4 equals multiply by 4. And now that can just be that. Fucking crazy.
Is the idea to be that explicit, or is it to eliminate variables if possible? 'Cause like that, you don't need that variable.
Right. I wouldn't do it, but I think it illustrates the point. And I would do it and have done it in the past if I think it makes the code more readable. Yeah.
So when, like, when would you use, like, functional programming?
That's a super good question. So my benchmark at its core, any functional program, sometimes in complicated ways, sometimes in fairly simple ones, takes in input, does a bunch of shit, and then produces output. And then everything in between was just turning that input into this output. If that, like, in a very straightforward way describes what your application does, I think functional programming is the right call. I can't remember if it was this group or this is probably all next yesterday. When I was at Health Scholars, like the main app that I worked on took teacher availability and doctor availability and room availability. Like it was like Google Calendar. You would like paint some availabilities on a calendar. You would take all those things together and come up with a list of options where all those availabilities coincide. So given an array of availabilities here, an array here, an array here, an array here, an array here, can you find the total intersection of all of those? That is a fucking FP by the numbers problem. And there was a procedural solution to that when I showed up. It was fucking 4,000 lines long. It was awful. Because there's so many different places a bug can hide. Like, when I was done with it, it was probably about 200 lines of very dense functional programming. Fairly difficult to read, but bulletproof. And on the occasions where I did have to change it, it was always incredibly clear where the change had to occur. And it gets real easy to test before and after, because you're just testing function inputs and function outputs. It's a chain of changes. So that's something I think functional programming really excels at. object-oriented programming, if it's a lot easier to think of your application as different nouns that verb each other, like, that's probably a good use case for FP. So data modeling problems, I'm much more likely to reach for OO for that. I did a demo yesterday of like the Develop Denver app, and that like representing people who buy tickets and have tickets and haven't redeemed tickets, that's honestly just a lot easier to do with OOP. So that's what we do.
Because what makes like a JavaScript language that can do either
Yes.
powerful is because
Yes.
like the Stack Overflow, it's easier to do the loop than to do.
We can just we can combine them at this, we can do it at the same time. You can do a big functional chain as a method in an object. That's wild. So we just get the best of both worlds and we get to effortlessly go back and forth between them. And it's undersold, but I think that's a reason why JavaScript has been as durable as it has. It's fucking crazy. Cool. Got time for one more, then you guys have surveys. One more question. So I think I want to do a follow-up to this because we didn't actually get to the practical part of it. And we went pretty far down the rabbit hole. I'm not all the way sorry about that, but there's some very practical ways that we can get used to thinking of code in a functional style, and that assessment's a pretty good example. So before the next time we talk about this, I'd like you to go over to this problem. There's not that much to it. It's this code, and you try to make sure that those things have occurred, and that is within all of your wheelhouses. But there's a library called Lodash that I get a lot of action out of, and there's like very elegant ways that we can solve that program that are new things to us. And so Lodash is just a collection of utility functions. This is stuff that like people have just been writing by hand forever, like flat map. If you map over something that produces a bunch of individual arrays, you get an array of arrays. A flat map just squishes all those into one array. Pretty straightforward. Or like map. Okay, well cool, we have map already, except this map works on objects like it did in Ruby. So there's like a couple of those kinds of things. Or that map also has something where anytime you're mapping over like an array of objects and you just want one property out of them, you could do something like, I just want all the user IDs. So I map over users. In Lodash, it would look like this. You map, I want every ID out of users. Fucking elegant. Yeah, dude. What the fuck indeed. And so there's a couple like tricks I'd like to show you, but another day. Wrestle with these ideas for a little bit, because this is heavy. This is the most like intellectually herdy thing that we probably do in the program. And hop over to your surveys. They're in Borg and elsewise. Thank you very much.